Oh, hi there. What's happening? Welcome to a virtual class of using graphs to estimate values. All right, so what we're going to do is we've been doing a lot of graphing, we've been finding equations, and now what we're going to do is we're going to look inside of graphs, and we're also going to look outside of graphs to determine things like how long it would take us to go a certain distance or how far we can go in a certain amount of time. All right, and we're going to be looking at two terms today. We're going to be looking at extrapolation and interpolation. And I, like to sing a little song, 2, 4, 6, 8, let's extrapolate. Yeah, I know. So what we're going to do is we're going to be able to use extrapolation and interpolation to predict values on a graph. Now, these terms are a little bit of vocab, and interpolation is using the graph to estimate values between points on a graph. And I try to remember this. This is interpolation is the interior. This is on the graph, all right? We just use the graph, all right? And so what we have now, let's take a look at this graph. This graph shows how the distance traveled by a car on the highway changes over a period of time. All right? So on our x-axis we have time, and our y-axis we have distance. Our time is the independent variable, and distance depends on the time. All right? So when we do interpolation, we're going to look inside the graph, and we're going to use the graph to answer certain questions. So what we're going to do is this next one right here, we're going to estimate the distance traveled in 1.5 hours. What we're going to do is we find 1.5 hours on our graph, and I'll put it in blue here. That's 1.5 hours. Then what we're going to do is we're going to go up all the way to our line, and then we're going to go over at 90 degrees. And this point where our graph hits on the distance is going to be that distance, an estimation of the distance that we travel in 1.5 hours. All right, so if we look, well, we know that's half, that's 150, so it's going to be about right in between, and we're going to get 125 kilometers. All right. Now, it says estimate the time it takes to travel 300 kilometers. So we're going to start at 300 kilometers, and we're going to go over. We're going to follow that line over, and we get right to this point. Well, we don't know it exactly, but if we go down at 90 degrees, we're going to find out, and that is about 3.75 hours, or 3 3/4 hours, which is the same as saying 3 hours and 45 minutes. That reminds me a little about a Dumb and Dumber quote. Why don't we meet at 7:40? Well, I got some things to do, so why don't we meet at 7:45? All right, sounds good. All right, so we've done interpolation. It's inside the graph. We start at a point, and we find the other point in our other variable. Now, let's move on to extrapolation. Extrapolation is using the graph to predict values that do not lie on the graph. All right, so this is outside the graph. All right, we often extend the graph in order to extrapolate. All right, let's turn the page. Now, suppose the same car maintains the same average speed. We need to predict the time it takes to travel a given distance. So what we can do is there's two strategies that we can use to find how far or how long the car is going to go. The strategy one is extend our line. All right, and if we were to do this, we would do this with a ruler, and we're going to extend our line all the way up, and then extend our graph, and we're going to find out how far we get for a given distance. And you know what? We're going to give a distance of 600 kilometers. We're going to find out how long it takes. All right. All right, so what we're going to do is we're going to go, we've got 400 here, we're extending our graph, about 500 there, and about 600 there. We could extend our other graph here, and it's going to be about 5, 6, 7, and 8. All right. So what we can do is we can go and use our interpolation now, and we can start at 600 and we go across. And remember, this is an estimate. We go down now, and it's about, if my line was perfectly straight, it's going to be about twice as long as it would take for 300 kilometers, which would be just under 4 hours, which will be just under 7 hours. All right. So now what we do is we could find out, so it's going to be just under 8 hours. All right, and that's our estimation, so a little estimation sign. Next, we have a different strategy, and we can have strategy 2. All right, and this is, we can make a table of values. And determine the equation of the line. All right, so what we're going to do here is we're going to make a table of values, and we have h on our independent or x-axis, and we have distance on our y-axis or our dependent axis. So we start at 0, hour 0, and our distance is 0. Then we have 1, 2, and 3. We just need a few different points. So at 1 hour, we go about 75 kilometers. At 2 hours, we're at about 150 kilometers. Now remember, this is an estimation. And then at 3 hours, we're at about, what are we at there? 250. All right, or 225. So it looks like we're going up by 75s here. All right, so we're going up by 75, going up by 75, going up by 75, and this is an estimation. So we follow the rules again. When we make an equation, we use the difference of our dependent variable. We circle it. We're going to multiply by our h. 75h plus something equals the distance. And we're going to fill in something for this. We're going to fill in using a point, and we'll go 75 times 1 plus something equals 75. Well, that something is actually nothing. It's 0. So our equation for this line is 75h equals d. Using our equation, we can put in the amount of time, or the amount of distance, and we can put in, we want to find out for 600 kilometers, so we're going to go 75h equals 600 kilometers. To get h by itself, we're going to divide by 75, and finally we get h to equal 8 hours. Now that's an estimation. All right, it's actually just a little bit less according to our graph. All right, so there's a few more examples in your textbook on page 194 and 195. You can check those out. And also, we're going to do on page 196, this is all, 4 to 11 all. We have to do all because they, all the questions, they all relate to each other. All right, now if you get done early, we do have some challenge stuff for you. This is extra practice 5. Alrighty, good luck you guys. Have a great day.